Hi, so as Tomek said, I work with Tomek on the MLOps platform at Allegro. And today, so answering your question, building or buying, the answer may be a bit different than Darek's. So let's start with some of the history. So it's 2019, and Allegro already has several models in production. We have visual search, we have ranking, we have some models for similar offers, and so on. And each of the model is maintained by a different team and using a different set of tooling. It's deployed differently. So some of the models are deployed in Java or in Scala or Flask, and some of them are deployed in Google Cloud Platform as a online prediction service. So we have already several different things, and we have a huge appetite for even more projects. So we can go with one of those two ways. And the first one is a microservice approach. And it has some advantages. For example, it's robust, it's fast, and it has good DevOps practices, for example, for logging and for monitoring and for metrics. But it's developed by the software engineers, and it won't be easy for researchers or data scientists to use it. And it's time-consuming to implement and to deploy, because every time you need to write it from scratch. For example, you need to write the downloading the model and everything you need to write from scratch. And we have also Google Cloud Platform. And it's easy to implement for researchers because it only needs the only a model, or it needs just a class that implements some interface. But it was beta at the time, as it's 2019, 2020, and it was really unstable, and it has huge latency. So it's okay for some of the models to have huge latency, like seconds, but not for all of them, especially for the fast ones, like the search ones, or like really latency sensitive ones. So we thought, what do we have right now? And at Allegro, we have our own data center with our own Kubernetes, and we have an App Engine, which is a tool, our own tool for deploying microservices, and it already has some of the tooling in place. For example, we have CI/CD, we have logs, we have metrics, we have Grafana, when we have some alerting system. So we thought, maybe we'll just build ML engine on top of the App Engine that we already have. So we end up with something like this. So the architecture is, we have the model service that we're deploying. That's our application that serves the model. And we have other services that want to get the prediction from that model. So the first thing we need to do is we need to download the model from our model repository. So we'll talk now a bit more how this model repository and downloading works. So as we said, it's Kubernetes. So we have a model service that's on Kubernetes, and we use a Kubernetes hook to download the model from cloud storage, where it's versioned. And also, we can download it from our own data center where it's cached, but it's not for all the models. And so we have versioning of the models, and we can download any model we want, and we can roll back if something goes wrong. So we have all the versioning. So now we have our model repository, but how do we version the models? So if there is a change in the code, we know what to do. We know that we need to have a pull request. We need to merge that pull request, and we need to deploy that model. And we have a deployed model to protection. But sometimes the change is only in the data, and then we need to retrain the model, upload it to cloud storage, for example, and it should be deployed. So the difference here is that this part is manual, and it should be manual, and every dev knows that it should be manual because we don't want code that just gets deployed to production by its own. And this part is often automatic because sometimes you need to retrain the model, for example, each day or each hour. So you don't want to have this manually. And that's the part that we had to add to the app engine. So unfortunately, we couldn't just use the app engine that we had. We had to add some more parts, so it's valuable. So it's viable for also the machine learning models. So now we have the model downloaded. So we can ask for a prediction, and let's go inside the model service. So it's a Kubernetes pod, and it has an orchestrator inside. And the orchestrator does several things. It gets the features from our feature store, and it also gets features from REST services. For example, when you have the another ML model that you want the prediction from, you can't really store it in your feature store. You have to ask for it online, and it's a really great feature. The only problem is that no one uses it. It's actually my fault that the feature was implemented because when I was in my previous team, I asked for that feature and I never used it. So now they make me work on the MLOps platform as a punishment. So that's just one of the features that we have that seem great, but like no one really uses. It also caches the features that it gets, so our request can go a bit faster. It has, but now how does it know which features to get? It has the declarative configuration that can request the features per object, because sometimes when you get requests for your to your model, you have several objects, and you can have per object features, or you can have per request features. So it's faster. And it also gathers metrics for the whole prediction process. So now we have the orchestrator, but we still don't have the prediction. So here, the orchestrator passes the request to the model class that's inside Python or a Java wrapper, which is just a library. And it supports Java because Java is the mostly used language in Allegro. And it supports Python because Python is the mostly used language by the researchers and data scientists. And it has an interface that looks like this. We just have the two methods, load and predict. And it's compatible with the GCP AI platform interface that was used previously, because now we can move the models from the GCP to our data center with a very low cost. And it's easy to implement for the researchers and the data scientists because that's what they know. They can just create a class and load the model there. And it's technology agnostic, so you can use any framework you want. You can use XGB or PyTorch or TensorFlow, whatever you want, or Onyx runtime. But it comes with a cost because we have those two things deployed as a sidecar. So it's so now we can deploy the changes to the orchestrator without redeploying all of the model apps. And so if you want to change, for example, the metrics that are collected or something, we can just deploy it separately. But it comes with a cost that it needs to communicate, and the communication is via HTTP. So there is serialization of the request, deserialization, serialization of the predictions, and deserialization again. So, and it adds up latency. And like in the beginning, we thought that it's not really that much of a problem, but it is a problem for the requests for the models that are really latency sensitive. And we actually added already changing the serialization from JSON to message pack, so it's a bit faster. But still, it adds some latency, and we are thinking about, for example, changing it completely because we want to have the lowest latency we can. So we have the whole MLOps, the whole ML engine on this diagram. So let's talk a bit more about the feature store. So we had some requirements for our feature store. So for example, we needed really low latency storage. We needed a seamless integration with the ML engine that we already have. And it should handle a lot of traffic. And it should be easy to use for researchers. So what we did is we have a BigQuery, which is our data source for the features in the feature store. And why BigQuery? BigQuery is commonly used at Allegro, and all of the data already flows through BigQuery. So it's just an easy way for everyone to just add the features in BigQuery. It's easy to use for researchers and for the data scientists because they use it every way. Everyone knows how to query BigQuery and how to put the data there. It's cheap and it's good for analytics. As I said, like most of the data already ends up in BigQuery anyway. And the ingestion pipelines in our feature store are users' responsibility. We don't care how the data gets there. We just need the data to be in the BigQuery, so it can be in the feature store. So it's technology agnostic, so you can use anything. You can use PySpark, you can use Dataflow, you can use whatever you want to get the data to BigQuery. So when the data is there, we obviously cannot use BigQuery as an online data storage because it's an analytical data storage. So we have Dataflow batch job that inserts the data to our data center, to our feature store in our data center, which uses Couchbase. The Dataflow job is runs hourly or daily, so it's just a batch job. It's not streaming. So why Couchbase? Couchbase has several advantages. For example, it has really low latency. It handles huge traffic, which in our case is hundreds of thousands of reads per second. It's already used in our organization, so we don't have to add another database and maintain another database. We already have the Couchbase and Couchbase specialists in our organization. It's not perfect for scalability because it needs to be scaled manually, but we don't really have that many spikes of data. We only need to probably potentially scale it when we add new features to feature store. So it's not that big of a deal. So we have our diagram. And there's another way of adding the features to the feature store. You can actually insert them in streaming fashion by Hermes, which is our messaging system, and it's based on Kafka. It's open source and it's standard at Allegro. So that's seems like a great feature, and it's another one that nobody uses. It's just there, and I actually didn't know it's there previously. So, but you can do that. And once you get your data in our feature store, you can just ask the feature stores for your features. For example, Orchestrator can ask for your features and reach the request to your model. So, as any good feature store, it's available for every team in our company. So we would like people to share the features that are in the feature store, so we don't get any duplicates. For example, when you get the offer price, you should be able to use the offer price. Like any team should get to use the offer price for their models, because why not? So that was the plan. But of course, in reality, it's a bit different. So in reality, no one wants to maintain the the features for other teams because it adds responsibility for your team, and it forces compatibility. So you cannot really experiment that much when you have to maintain the features for everyone. And it's actually a bit more of a problem because the features may mean different things for different teams. So it's not that easy to maintain just one offer price for everyone because the context matters. So it may be a bit different from team to team. Another thing that is great with feature stores is that you have offline features as well. So you can train the model on the same data that you will have in production. So that was the plan. And again, the reality is a bit different. So in reality, features change. And every time you change a feature, it breaks the historical consistency of that feature. And you would have to backfill the data so you would have the correct version of your feature. And backfilling the data is really expensive. Sometimes the models need, for example, a year of data, and a year of data in Allegro scale is petabytes. So it's really expensive. So we don't really do that. And the other thing is that the tables and the queries for training may differ from the ones for the online prediction. And they differ for a reason. For example, for training, you may need just the offers that were clicked. And online, you cannot use just offers that were clicked, obviously, because you don't know which one will be clicked. So it may filter a lot of data for your training. So you actually want the data for the training to differ. So that's another thing that is not really that commonly used in our feature store. So the lessons learned here is that sometimes it is easy to build a custom platform, especially if you have already many tools available for you, like with our app engine. But you need to know that it's not the same as developing the microservices, the apps as microservices, and some of the features need to be added to your tooling. For example, the automatic deployment, and it may sound obvious, but it happens all the time. So if you don't need a feature, but the feature is just there in other solutions, you don't need to add it to your solution, which yes seems obvious, because then you end up with just fast data storage with a few extra steps, and that's what we end up with our feature store. But don't get me wrong, the platform is really working great for us, even if it has some features that no one uses, and it handles tens of models in production, and thousands of predictions per second, and hundreds of features in the feature store, and hundreds of thousands of reads from the feature store. So thank you for that. And do you have any questions?
Thanks for the presentation. I have a question, not sure if this is a question for you or maybe for someone else in Allegro, but some of the problems that you mentioned about the feature store are promised to be solved by a data mesh approach. I'm curious if this is something you are trying to use, and what are your experiences with it, because it makes many promises, but it's at this point hard to say, how successful those promises are.
So data mesh, as I know, is just is a work in progress right now, and we don't have the feature store is not for now not it doesn't use the data mesh, but we are thinking about it, and it's still you have to make, for example, because you're probably thinking about, for example, reusing the features for other teams. So you still need to find someone who will maintain those features, and some teams don't want to agree to that. So it's still a political issue, not only a technological one.
Thanks for the presentation, very interesting one. I have a question about your approach to monitoring and metrics. So you showed that you use Grafana, and I was wondering, are you pushing the metric to the server, to Prometheus server, or are you storing them in the database, or what is your experience here?
So the metrics are, we use Prometheus. We use actually, we have also Graphite, but we're moving to Prometheus right now, and we keep the metrics there. And I actually am not an expert with those metrics because it's something that I get for free from our app engine. So I'm not an expert in the metrics topic. But we have the Prometheus, and we have the Grafana that you can query the Prometheus metrics, and we have some alerting based on those metrics as well.
Hi, I'm thinking in the end result of the model is a feature, so why don't we keep these results in feature store?
So you probably mean that the REST features, that you can actually have the results of the model as features in feature store. So features, so you can have those features in feature store, but sometimes but it will work like caching. So sometimes there are predictions that shouldn't be cached and should. For example, they have to be randomized, for example. So you cannot really put them into feature store because then, for example, each instance would get the same not randomized result, and they should be randomized, for example. So not every feature can be stored in feature store. Does it answer your question? Because I'm not sure. Okay, thank you.
Hi, thank you for this presentation. Very interesting story of machine learning engine development. So I'm more interested in the organization structure. How many people work on this project and how you were organized?
That's a great question because it's difficult because the whole platform was not built by our team, because our team actually came into existence not that long ago, and it was after the ML engine and feature stores were built, and it was just one team of several developers that were building the ML engine and another team that was building a feature store. So that's not a huge team.
How do you think about transparency and sharing the learnings between teams? What I mean by that is you mentioned the problem of ownership of the features, and probably a related use case maybe findability and understanding what features are there and data lineage behind them. Is data catalog something that addresses those problems, or maybe you have a different approach?
Thank you, great question. It's for a lot of so we have the data catalog, and we are introducing it to more and more data that we have at Allegro, and we also have we are introducing data mesh, and so feature store is not now. For now, we don't use the data catalog, but it's something that we are thinking about. And but still, like if the teams don't want their features in feature store to be used by other teams, then like we cannot do that much about it. Even like someone may find it in the data catalog, but still it may change from day to day if the team decides that the feature should be dropped or it should be changed for some reason.
Hi, I have a question if you have like a structured approach to the validation of those models. So you develop a model and you mentioned the model repository and you have like tens of models, up to 100 models in production. And then, you know, during, for example, COVID, many models broke down and the prediction failed. And then, you know, one way to account for that is to have a validation of the model that is independent from the model developer. So kind of review on a cycle basis. So do you have such kind of thing, or it's kind of more organic and improved by the model developers?
It's mostly maintained by the model developers. We don't, as the MLOps platform, we don't really care that much about what models are deployed. We just care that our platform works, so the models are validated by the teams, and it differs from model to model.
Great presentation. Does the platform cover all of the models that run in Allegro, specifically like feature stories more probably for tabular data? Do you also serve like the NLP models or the computer vision models, or is that a different platform?
So most of the models are deployed to ML Engine. Not all of them, but it's not really the case like of the type of data, but just some of the teams wanted to have just their own microservice that they can manage better than, because you know it always adds like some stuff that they can't really manage that well. So some of the teams wanted to have their own microservice, but we have like the image models and natural language models in ML Engine, but they just sometimes don't use the feature store, because like for example, when you have an image model, you probably need the image to be in the request anyway, so you don't get it from the feature store, but from the request.
So what's your another question? Sorry. So what's your like dream scenario in the next 2 to 3 years? Like, how would that platform evolve? Like, what do you want to build? What do you want to change? Like, how will it make the life better of your machine learning developers?
Oh no, that's a great question. That depends how many people can we hire, probably, because we only have one team right now, and so we are swamped with creating some other tools. So I don't know how much I can share about the plans that we have. So yeah, we definitely have plans of making the ML Engine faster, and we will definitely rethink if building a custom ML Engine is a good idea, or should we should we adopt some tooling that's off the shelf. But I don't know what exactly will happen.
Good luck.
So thank you for the presentation. And my question is, because I can imagine that you have like a huge team of data scientists and machine learning engineers that are working at Allegro. So maybe could you share how does it work with like training process? Do you have like a big, let's say, like big training machine that has the most powerful CPU and GPU, or you're like training it locally, or?
Yeah, locally on our Macs. No, so for the training, most of the teams use Google Cloud Platform, so they can get any GPUs they want. And we don't have that much standardized at the moment. So we don't have that much MLOps tooling for that. It's every team on their own, mostly. But we're working on it, so don't worry. Maybe next presentation will be about it.